All right. So I used to work with University Extension. I was extension agent for Jackson, Trempealeau, and Buffalo counties for about 13 years. Anyway, then a year ago I switched, and now I work with Short Lane Ag Supply, and I manage the Pigeon Falls location. We sell seed and herbicides and a lot of grass seed, clover seed, alfalfa that would interest this group, but we also sell all of the corn, soybeans, herbicides, all of that stuff. I'm going to be talking about soil health today, primarily from a soil fertility standpoint. I don't sell much fertilizer out of the Pigeon Falls location there. We broker loads out of Winona, and I have some bagged fertilizer and that type of stuff. So I'm not doing a sales pitch on fertilizer today. I'm trying to give you some good background and good knowledge of soil health and soil fertility. So I want to start off with how do you define, you in the audience, define soil health? Anybody want to volunteer that?
Microbes.
Microbes? Yep, good. A lot of microbes. Anyone else? Worms? Yep, worms, the micro animals in the soil. Right. Anybody else?
Compaction.
Compaction? What about compaction?
Well, it's not compacted, it can't breathe. It can't breathe, it dies.
Sure. So compacted soils are not healthy soils, right? So anyway, my take on soil health, when I first started hearing about soil health, when it first started coming about, in the mid to late 90s, I was like, well, how in the heck are you going to measure soil health? I mean, what is soil health? We go to a doctor, they take your blood pressure, take a little blood from you, poke and prod here and there and come up with whether you're healthy or not. We can do the same with livestock, but soil, how in the heck do you. And I just had a real issue with this whole idea of soil health. I know what a good soil is. It's tilthy, and the old analogy that it looks like chocolate cake. It's dark, it's crumbly, it's soft. So anyway, as I went through, what is soil health, I came up with, this is kind of my definition. So a healthy soil allows for optimum water infiltration, optimum being dependent on soil type. Obviously, a sand is going to infiltrate a lot more water than a clay, but a given clay soil will infiltrate an amount of water, and then a compacted clay soil or a clay soil that's had crop residue removed every year forever is going to infiltrate less, and so forth. So that optimum amount. And also, maximum crop growth, regardless whether your crop is corn or pasture, maximum crop growth with the appropriate amount of inputs. We're not, the no input idea is not necessarily good, and also the maximum input idea is not necessarily good either. So appropriate amount of inputs and minimizing the impact of production agriculture on neighboring ecosystems, okay? We all use our local ecosystems. That's my wife and son out trying to catch some trout in Pine Creek in western Jackson County. So it was a great afternoon. We worked all day, and then let's go fishing. So we grabbed the fishing rods and went and tried. We didn't catch anything, but we sure had fun and spent some time together as a family. So we all use and enjoy our local environment and ecosystem, and we don't want to impact that negatively. And we know that if we don't take good care of our farms, our businesses, that somebody else is going to come up with an idea of how we need to do that. And the people that come up with those ideas a lot of times don't have a good understanding of why we do what we do or why we do it where we do it. And we can get all kinds of conflicts then. So if we're all good stewards, hopefully we can avoid some of that. Now, you guys grazing do a fantastic job. You know, you've got plant growth out there 365 days a year. Generally, everything is covered. What this picture is here, and I debated whether I should use it or not because it's hard to see it. There's a man standing in a gully there, and there's a series of pictures that go with this. There's a zoomed out angle, and there's an old barn off on the left side there. And this was a lane coming off of a hill for this person's cattle back in 1930s, 1940s. And this gully is up over his head where the cattle walk every day. So in well-managed pastures, we can still have areas that, they need a little work, need a little attention. And what I'm going to focus on is nutrient levels in your pastures. Okay? I'm not data heavy, more of ideas. You know, let's challenge what we're doing here. So, you know, to focus on soil health, the grain guys that are doing soil health now are planting cover crops after soybeans, wheat, doing some interseeding in the corn to get living roots in the soil the most amount of the year that they can, and that sort of thing. You guys are also doing that just with having, you know, pastures out there, grass, clovers out there year-round. The roots are alive now. They're dormant or, you know, respiring very slowly, but they're still out there. They're still alive generally, we hope. And so that's working for us, but there's still some things that we need to do. So to maximize the ground cover and get that good mulch layer out there on top of the soil that we all want in our cropping systems, we need to maximize that growth. In order to maximize that growth, we need optimum nutrient levels. Okay? So growing grass and clover without proper nutrients is like trying to produce meat and milk without feeding the cattle. Okay? You can do it by skimping, but you may not optimize that. And then soils are like people. These young people here, they look healthy. They're not overweight. Skin looks clear. They, you know, we don't see them smoking a cigarette or something like that. But we could send these people to the doctor and there could be underlying problems. So you could look at your pastures and you're like, they're green, we got good growth out there, everything, but do we have something hidden in there that out in those pastures that might need some attention? So that's what we're going to talk about today. So any questions, comments so far? So anyway, we need to kind of look, you know, under the hood, so to speak, to see what's going on in our pastures, make sure we're at optimum levels. Okay? Okay. So you start with soil testing. Okay? Obviously in a paddock where you have a corner where the cattle congregate for water, or maybe there's a couple trees, some shade, you want to stay out of that area when you're soil sampling, or take a separate sample from that area to see what you've got. Maybe if you can, move your water around to another corner if you're getting a concentration of nutrients there, destruction of ground cover, that sort of thing. So there's some things we can do, but the soil probe is going to be your most important tool. And also, when I'm soil sampling a field or a farm, if I'm going to be, back in the day when I was going to farm it, I would bring a soil probe with me and I would walk around that farm before I agreed to rent it or anything, and so I knew what was out there, and that's very important. If I'm soil sampling for a customer, just, like out of my own curiosity, I'll texture the soil and see, kind of what it is, silt loam, sand loam, whatever, but I'm kind of a nerd about that. I kind of enjoy that. But it's something that you can just add to your base of knowledge as you're out there. So you can go all the way up to, GPS grid sampling and sample on 1 acre grids and all that stuff. Gets a little pricey. You get a lot of information that way. I mean, it'd be a great way to manage your soils, but I don't know if you're going from no samples. I think your first step would just be sample, by paddock, or if there's different soil types out there, maybe that back corner is kind of a sandy piece and this is heavier ground up front, just sample it that way. University recommendations is a sample for every 5 acres, however you want to do it. Start off, you can always kind of fine tune your next round, 3 to 5 years later when you pull another set of samples, you can fine tune from there. Send the soil samples to a Wisconsin certified lab. Okay, when I was with the university, I had to tell you that. Okay, I'm not with the university anymore, but it makes sense to do that because the university, the Wisconsin certified testing labs are not certified by the university, but by DATCAP. There's a set of directions on how to sample a soil or test the soils, the reagents to use, the testing methods, that sort of thing. And also then the results are calibrated for Wisconsin. So if you send your samples to a lab in North Dakota, for instance, they're going to use different reagents. Particularly, western soils have calcareous soils, so they're going to use a different reagent to test for phosphorus. You're going to get different results than what you would get from Wisconsin. So you want to make sure you use a Wisconsin lab. So what they do is they take, when you're filling out your information sheet, designate pasture, and there's different categories of legume pasture, straight grass, that sort of thing, and then that'll generate the recommendation on the back end. Another line on there that's important is soil type. Okay, so the biggest thing you want to do is make sure if it's a sand that you've got a sand soil, or a silt loam, you've got a silt loam soil. That's the biggest thing. You can be general about what your soil type is. The folks at the county can help out with you finding your soil type for your farm. University Extension can help with that, because the recommendations are calibrated to each soil type. So what has happened over the years is they test these soils and they come up with, okay, we have a Fayette silt loam with 10 parts per million phosphorus. Okay, so how much phosphorus should be applied to this Fayette silt loam? And then they put it out in test plots and they apply fertilizers in these fields. They try to find fields with low or high or whatever soil test levels. So that's how they calibrate it. And the recommendations are based on a probability of response, okay? And the test results you get back, 10 parts per million, that tube of soil so you go out, you got your field, take your probe, collect yourself 5 to 10 cores, put them in a bucket, put it in a bag, send that into the lab. They dry it, grind it, take even a smaller subsample. So your first sample is a subsample of the field, The lab takes a subsample of your subsample and tests it, okay? Then that 10 parts per million is what was in that subsample of the subsample, okay? It's not 10 parts per million in that acre. There's going to be a lot more phosphorus in that field, but whether it's going to be available to the plants at any given time is another issue, okay? So don't look at that, because I hear people say, man, there's so much phosphorus out here. If we just test this soil, there, in the rocks, in the soil and everything, there's, tons of phosphorus, tons of potassium per acre. That's true. But don't discount the soil testing process because of that, okay? So the categories, the high, optimum, low, whatever, are built on a probability of response, okay? So if we look down here at the bottom, corn, grass crops, soybeans, clovers, the optimum phosphorus level for a silt loam soil is 16 to 20 parts per million, okay? So at that optimum level, you are applying basically crop removal of that, okay? So if your corn crop takes off, 50 pounds of phosphorus, you should apply 50 pounds of phosphorus to that field. And yes, cattle do urinate and defecate on the pastures, and that's a really good thing, okay? And in the later, right before I'm done, I'll touch on why grazing corn stalks is a good idea because of the urine and defecation. But you're going to deplete your soils about 15% per year just by exporting milk, meat, and wool off of those fields, okay? So you are taking nutrients off of there. Now, if we look at potatoes, that's why you got to put your crop on that sheet, what you're growing. If you look at potatoes, the optimum phosphorus level is 161 to 200 parts per million. So those potato guys are really hammering the phosphorus to those fields because potatoes are a high response crop to all nutrients, really. So, any questions? Okay. Okay, so breaking down each category you're going to see on your soil test report, I left organic matter off of here just because, yes, we're going to increase organic matter in a grazing operation, and we do get nutrients from organic matter, but we're going to pick that up in the soil test, okay? The soil tests will pick up those nutrients that will become available from just the normal organic matter cycle. So I don't address organic matter in here at all. I'm not saying it's not an issue, but we'll just leave that for another day. But pH is the most critical thing you need to watch in your soils, regardless whether you're pasturing or growing corn or soybeans or alfalfa, whatever, okay? So pH affects nutrient availability, okay, and rhizobia bacteria, okay? And rhizobia bacteria are specific for each legume, okay? Alfalfa has a different species than soybeans and a different species than red clover. So that's why you get soil recommendations. If you're growing clover, put on your sheet you're going to grow straight red clover, your pH is going to be 6.2 to 6.3. You check alfalfa, your pH is going to come back at 6.8. Not because the plants need that, but because the rhizobia bacteria need that. That's why you can grow corn or brome grass on a soil that's below 6 pH, because you're not relying on rhizobia bacteria. Now, what's going to happen in the future if or when we get grass crops that can fix nitrogen? I don't know, okay? So adjust the pH to the range for the crops you're going to grow, okay? Use the most economically priced lime material for your area, okay? So here it's quarry lime, calcium magnesium carbonate, okay? Magnesium does not cause compaction, okay? I hear that a lot. Oh, I use high calcium lime because magnesium causes compaction. Now, calcium does help soil structure. It helps the soil particles flocculate, which means come together and form our nice little aggregates that make that chocolate cake type thing that we all want. But it's not a presence of magnesium that's going to cause compaction. It may be an absence of calcium. But Wisconsin soils, especially the driftless area here, we are high in calcium, okay? So if we put it into test plots, and this has been done time and time again all across the Midwest, where you're pick a crop, whatever crop you want, apply calcium to it, you do not get a yield response. Certainly not an economic yield response. Now, I've heard people say, oh, I sprayed this liquid calcium on my pasture and man, everything got green. Okay, I won't argue with that. Okay, and if it's working for you, go ahead, keep doing it. But I suspect if we put out some tests out there with actual, areas within that field of zeros and took some weights throughout the year, I suspect we would not have an increase from the calcium. That's me. So gypsum or calcium sulfate does not alter soil pH, okay? What we need is this carbonate, this CO3 ion here. And this is calcium carbonate I have in this reaction. Same thing happens with magnesium carbonate. So what happens, hydrogen is our acidifying ion here in the upper Midwest. When you get into tropical soils, it's aluminum, and then we got a whole host of problems with that. But we apply our lime, calcium or magnesium carbonate reacts with two hydrogens. So basically this splits, okay? The calcium is a +2 charge. It pushes two hydrogens off of the cation exchange capacity. We have calcium, we have carbon dioxide, and water is formed from that reaction, okay? Or magnesium, carbon dioxide, and water. So that's what neutralizes our soils, okay? So in the calcium sulfate, there's no carbonate atom there to react with the hydrogen and basically tie that up, make it not an issue, okay? Okay, and it wouldn't be a good soil fertility talk without this chart. We all saw that probably high school ag class and various popular press, out there. So this is, the nutrient availability changes with soil pH, and we can get too high, have either very high levels of some nutrients or very low levels of nutrients available for the crops. So you get out into the Dakotas and west where they have the calcareous soils there. Some of those are up 8 pH. They have to start doing some really weird things to get phosphorus available for their crops, okay? Banding it with anhydrous ammonia in there for corn and that sort of thing. So it gets to be a real issue. Too low, then we start having issues also. Lately, in Wisconsin, we're starting to find some fields that are very low pH. When we first started farming in Wisconsin, over 100 years ago, in this northern area, we were fighting low pHs and poor crop growth. University came out, put on lime. Everything was good. We started growing alfalfa as dairy caught on. We're liming up to 6-8 for alfalfa in the rotation. Everybody was happy. Now the cows changed zip codes, and we've got fields and farms where we're not growing alfalfa. So now all of a sudden, we don't need to worry about pH for corn and soybeans. Well, now we're starting to see some of those fields down in the 5s, even some 4.5s in areas. And there was one field up by Durand, Dr. Carrie Lebowski, this was probably 7-8 years ago. She was called up to a field up there, had a big dead spot in the middle of it. It wouldn't even grow corn. And they started poking and probing around. The middle of that dead spot was about 4 or 5 pH. It just wouldn't grow anything. They put lime on it. It was a sandy spot too. They put lime on it. Within a few years, pretty soon there was corn growing again. So we got to watch pH. Okay. Now, like I said, gypsum does not affect pH, okay? And I feel I've got to address this just because there's a lot of stuff out there about gypsum. Gypsum is a real good sulfur source, but if you want calcium, it's a good calcium source too. But it's a little on the expensive side compared to other forms that are out there. So, just be careful applying gypsum to your fields. Watch out for some of the hype that's out there. If you're going to be applying it for sulfur, you're going to be down at tops, a couple 100 pounds per acre. Even that's a high rate. There's some hype out there of putting it on, a few tons per acre because it affects soil compaction. Where gypsum, they use a lot of gypsum in irrigated western fields where they start having salt contamination. Okay, so surface flood irrigated fields where you're sharing a canal through a whole county. The poor guy down on the tail end of that canal is getting salt water, sometimes. And then you've got to apply gypsum to flush that sodium out. What happens when you get a sodic soil is, if you look at clay minerals under an electron microscope, they're in sheets, like stacked up pieces of paper or a scaffolding. And what sodium does is it causes that to just collapse. And the clay when it gets wet, it's just like snot. So you put the sodium or the gypsum on there, you flush the sodium out, and then everything fluffs back up and you got good soils again. So we don't have sodic soils in Wisconsin because we get enough rainfall. We're not doing flood irrigation. Where we're irrigating, it's not saltwater aquifers and that sort of stuff. So if you had some type of accident, industrial accident on a field, or way over application of whey, that can cause sodic soils here in Wisconsin. Generally, stop putting whey on them, and in a few years, you're good again. And you may want to put some gypsum on in that situation. But
what about using sheetrock?
Same thing. Yeah. Same thing. If you're organic, you can't use sheetrock. It's got to be from a certified organic source. But yeah, sheetrock is gypsum, and depending on what size the pieces are, it may take a while for them to physically break down, but that's not necessarily a bad thing, So, yep. Any other questions?
You mentioned something about grass fixing, maybe in the future? Or?
Well, from the corn standpoint, they're trying to get corn that that fixes its nitrogen, and there's a gene in tropical corn and some tropical corn that they're trying to get into, Midwestern corn that fixes nitrogen. That's more from the air. It's not really soil-borne like rhizobia bacteria, but who knows what these guys are going to come up with some of this gene splicing and that sort of thing. I just threw that out there as a little thought. But I don't know how much the fertilizer industry wants, corn and grass that fixes nitrogen. But we can get, nitrogen in our pastures just managing for clover, So that's really not much of an issue there. So, nitrogen and sulfur. So just touch on this briefly because it's easy to talk about. Maybe it's not easy in practice out there where you guys are, to make sure you have good clover in your pasture stands. So as long as you're 30% or more of your sward as clover, then you should be getting enough nitrogen out there. And sulfur is provided by the manure, okay? So as long as you're getting manure, as long as the animals are going to all the corners of your pasture, you're good on sulfur. As the organic matter level increases through well-managed grazing, you'll get sulfur coming off of that organic matter. Pastures seldom or never respond to sulfur applications, okay? Now, manure from legumes. The legumes do not leak nitrogen out as they're growing, okay? The way that nitrogen is supplied is we harvest that clover, however, mechanical, cows, whatever. We harvest that clover, and then there's a corresponding root dieback, okay? Because let's say we got a clover plant out there about this tall. Just for sake of discussion, we've got about that much roots out there too. It's about equal on most species. Some species more roots than others, but so it's not just water and nutrients going up to the leaves. The plant is moving water and nutrients back and forth, okay? So we're moving carbohydrates from the leaves, from the photosynthesis back down to the roots. The roots are exuding different compounds out into the soil to help the beneficial bacteria in that. With legumes, the plant is feeding those rhizobia. It's an actual infection in the root where those rhizobia are, and the plants are feeding those bacteria. It's not just free nitrogen. We're giving up, yield to feed those bacteria, but it works good for our system because we're getting nitrogen for the other 50, 70% of that stand out there that's grass not fixing its own nitrogen. So it's a good thing, okay? But the plant has to be harvested one way or another to get that root dieback, to get that flush of nitrogen out there. And that's how, so white clover doesn't leak nitrogen out. Red clover doesn't leak nitrogen out because it's expensive for the plant to make nitrogen. Takes a lot of energy to feed those bacteria. So they're not going to just willy-nilly leak nitrogen out and feed the soil as it's growing. You think of making nitrogen fertilizer, the Haber-Bosch process. You've got those big natural gas pipelines and you're burning tons and tons of energy to get nitrogen out of the air to make anhydrous ammonia. If that plant had a leak going out the backside and they weren't capturing all the nitrogen they were making, they wouldn't be in business long. It's the same thing with clover. It takes a tremendous amount of energy for a legume plant to fix nitrogen with the rhizobia bacteria. So we've got to have a harvest going on out there, okay? Another little pet peeve of mine is the talk of ratios. You gotta, whatever they are, you've got to have a certain amount of calcium, certain amount of, ratio of percent of phosphorus, percent of potassium. Plants don't care about ratios, okay? Early on in the science of soil fertility, they were doing ratios, and what they weren't realizing was they were actually just altering the amount in the soil, and they were getting to a sufficiency range, and then that's what the plant was responding to. But the plants don't respond to ratios. Then phosphorus does require energy to be taken into the plant. So it's active transport, so you're not going to see an excessive amount of phosphorus in the plant, okay? Just because it takes energy, they're only going to pull in what they need. Potassium, nitrogen, and sulfur are taken in by mass flow. So in other words, they're dissolved in the water. As a plant takes the water in, uses the water, and respirates water back out, the minerals stay behind. So that's how that comes in. Just as the water is coming in, it's dissolved in the water. Generally speaking, luxury consumption does not affect plant growth. Okay, so if we're pulling in a lot of potassium, a lot of nitrogen, it generally doesn't affect plant growth unless we're getting like super, super high levels, like a contamination type effect. Then, of course, we'll have some issues. But on the other hand, we can get some animal health issues, particularly with potassium in dry cow rations and that sort of thing. But from a plant growth perspective, we don't worry too much about luxury consumption. Now, that's where your soil test comes in. If you've got high potassium, for instance, you're not going to apply potassium, okay?
I have a question about the top line up there.
Yep.
P and K levels will be depleted by 50% per year.
Yep.
Well, I haven't used any fertilizer other than manure in 35, almost 40 years. I graze, but I still have, my pasture's still growing.
Sure.
I'm not quite following that comment up there.
Yeah, so that's, first of all, that's kind of a general, so are you feeding here's a scenario. Cows are in the barn, they get milked in the morning, they get fed corn, maybe a little corn silage, then they walk out onto the pastures. Well,
I don't feed any corn at all.
Okay, but I'm just thinking here, so they've got nutrients in them from a different part of the farm that they're depositing on the pasture. Could be a situation there. And then it's 15%. So 15% of 100 parts per million is 15 parts per million. Then if we drop down to 50 parts per million, it's 7.5. See? And you're going to get a soil down to its like native level where it's just going to cycle nutrients at that level, and you're not going to go much lower.
Okay.
You can go lower, and you'll still get some growth. But, yep. And we're still learning more about, this soil health is relatively new, so we're still learning how that works. I don't doubt that one bit. And when I say add potassium or phosphorus, I'm not saying go to the fertilizer plant and get a spreader buggy and drive it. It's nutrients, whether it's manure or you purchase some turkey manure or, something like that. So there's a lot of different ways you can go. And also for organic matter accumulation and organic matter mineralization, on a sandy soil, you're not going to accumulate organic matter as fast as you will on a clay soil, because the stable organic matter that we really want needs to be included with clay to protect that. So some of our sandier soils around here, we're not going to get that high organic matter. Well, it'll be more difficult to get that high organic matter. So our mineralization off of the organic matter will be less. But I don't doubt that you can get more nutrients out of a soil when it's healthy and you've got a lot of mycorrhiza and bacteria and other fungi in there. Yes. Was there a question? Yes.
Okay. How many folks in the room buy hay? Does the nutrients in the quality of that hay bale that you can buy, right, prime alfalfa baleage, or you can buy very, very nice grass hay, how do those nutrient values carry over once the cows are done with it? Because really, in purchasing hay, we're purchasing fertilizer that's masquerading as feed, correct?
Right. Yep. And regardless whether you're feeding a TMR in the barn or pasture or hay in a round bale ring, most of the nutrients in that hay pass through that animal. So the best job we can do to capture those nutrients and get them back out onto the land, the less fertilizer, the less nutrients we need to import to the farm. Okay, a little bit about phosphorus. So like I said, phosphorus is absorbed by active transport into the plant. It takes energy to get the phosphorus in. Phosphorus is not highly available. It's tied up in a lot of different soil structures and everything. So phosphorus is low. Available phosphorus is low in the soil. Okay, we can have tons of phosphorus out there on an acre tied up in rock minerals and that sort of thing. By rocks, I mean tiny little soil particles. But we need phosphorus. The plants need phosphorus for the energy cycle, making ADP out of ATP. And it's also essential for DNA and RNA formation. And we don't just use DNA and RNA when the plant is reproducing or the animal. DNA and RNA govern all the functions within plants and animals all day, every day. And so phosphorus is used in small amounts in the plant, so we don't need a lot of it out there. And phosphorus is recycled in the plant, like in the energy cycle. That phosphorus that's broken off and you get a burst of energy, that just cycles back around. It's grabbed again and that thing just spins, recycling the phosphorus. Now, if you have a phosphorus deficiency, the plants will not respond to nitrogen and sulfur. So that's another thing we've kind of discovered here in the state as cattle and livestock moved away, that some of the, we were all concerned about high phosphorus. We can still have that in areas or individual fields, but we're beginning to draw our statewide phosphorus levels in our fields down. Now we're starting to see some phosphorus deficiency where the corn, the crop is short and yellow. Well, what do you do when you've got short and yellow corn? You put more nitrogen on. It never greens up. Check your phosphorus levels, because that's starting to show up. Okay, potassium. Like I said, potassium is absorbed by mass flow, so it just comes in with the water into the plant. Okay, so if we're drought situation, we're not going to be getting potassium into the plant because we're not getting water in. Okay, so potassium is essential for water balance. Just like in our bodies, we need electrolytes. Potassium is an electrolyte for plants also. It works as kind of an antifreeze in perennials, particularly alfalfa and clovers. Just helps with the water balance so we don't get too much or too little in there, and that can affect our winter kill. So in a moderate winter kill year, we seldom see heavy winter kill in an alfalfa field that has a high level of potassium in it. You know, it just works that way. And the biggest thing that it does for us during the growing season is it regulates the stomata growth, or stomata opening in the plants, because we have to have air exchange in the leaves. And so these guard cells around the outsides of the stomata bring in potassium, and which brings in water, and then those guard cells open and close on that stomata. So that's what we need potassium for. In conclusion, we need the optimum fertilizer levels to optimize plant growth. Okay, optimum fertility level, sorry, not fertilizer. And test your soils at a Wisconsin lab. Okay, that's a good place to start. And marketing products off of your pastures will drop the nutrient levels. Kind of the rule of thumb is 15%. If you guys are observing less or more, okay, you know, that's just kind of a rule of thumb there. Pastures, you're not going to get a response to sulfur because of the manure out there. And nitrogen's best supplied by legumes. If you look at fertility recommendations on a grass pasture with no legumes, you're applying about 100 pounds of nitrogen. Okay, I just got a price for semi-lot size loads of urea yesterday, and we're up around $500 a ton for that out of Winona. So you pay at Winona, put it on a truck and haul it to your place for about $500 a ton. So that makes some pretty expensive nitrogen, you know. So if you got to put on 100 pounds of nitrogen per acre, all of a sudden managing for legumes becomes a profitable enterprise.
Steve, is it beneficial to do a 50 pounds, take a crop 50 pounds on nitrogen?
Right, yes. Yeah, you don't want to put that full dose out there. Yeah, do a grazing through in the spring, put some nitrogen on, do another pass or two and put a little more on. Right. Yep. Okay, any questions? I think this is our break time, Mary, or at least it is for me.